Hi and good morning, everyone. Welcome to this March DIGIPRINT webinar entitled the Printhead Masterclass. The goal of today's webinar is to have more insight and better understand how printheads work, how they are made or what they are made of, how you should handle them, and we also have a bunch of installation and replacement tips for you today. I'm going to try and keep it as general as possible. I'm not going to talk about one specific printhead brand or even model. I'm just will use some printheads from time to time to illustrate what I'm saying. But in general, it should apply to all printheads, or more or less all of printheads that are used today on the market. As usual, in the end, there will be time for questions and answers. This will be today a larger part of our webinar. Usually it's quite short, but I would like to use the opportunity to answer as much questions as possible today. Also, as usual, the webinar will be viewable again after the webinar is finished on our YouTube channel and on our Zendesk support channel. All right, I'm going to start with showing a presentation. I'm going to share my screen for that. Go full screen. Yeah, you should see my screen now. So, Printhead Masterclass. Now, the first thing that I would like to discuss is printhead technology, what we have today. And the reason for this is to help you understand better how printheads work and what they are made of. The printhead type that we discussed today is drop-on-demand, or DoD. Another printhead type is thermal printheads, but that's not used in our market anymore. And memjet, which is a newer technology, is not used in our market yet. So drop-on-demand, piezo printheads, and you can see here a schematic drawing of how it works. So basically you have a nozzle face, you have an ink chamber, and you have a piezo element, and at a certain time a positive current or amplitude will be run through the piezo element on a specific place on the piezo element, which causes it to extract. More ink comes into the ink chamber, and as soon as the positive current is gone, the piezo element returns to its original state, ejecting a droplet. So if we look at the animation here on the right, I'll start the animation, you can see how that works. There's actually two different versions in this animation. The one on the left is what this described in the image on the left. So with a current attached to a positive element on the piezo element, and the right has actually a current run into an enclosure around that ink chamber, causing waves. So it doesn't retract anything, it just ejects droplets by waves. 80 to 90% of the printheads that are used in our market today, large format printing and super white, are of this type. And most of them are actually shared walls. So you can see that here, where you have the piezo elements in red, and a current is run through them. So they deform, allowing more ink in the middle chamber. So loading ink here while ejecting ink to the left and the right. So there's always two nozzles at the same time firing. Okay. Now, if we look at the type of drop-on-demand printheads that are out there, there's the binary one, which has a fixed drop size or droplet size, and there's variable drop size, which is not grayscale, and then of course there is grayscale. The difference between variable drop size and grayscale is that a variable drop size, for instance, which can eject a 10 picoliter droplet and a 6 and a 2 picoliter droplet, so it has 3 different sizes of ink droplets. It can only eject those droplets one at a time. So you load a job on your printer, you select a mode on your printer, and that results in printing with 10 picoliter droplets. The next job you load, you choose a different mode, and you've got 6 picoliter. So it is capable of changing the drop size, but not in one job. Grayscale can do that in one job. And the advantage of grayscale is that you will have a much finer result, a printing result in photos. You won't see much difference in solid colors. You will see differences in gradients, but just a lot of extra benefits with grayscale. Just saw my, hang on a second. Yeah, I'm still there. Just saw my camera going away. I was just checking. All right, so variable drop size, look at the animation. What actually happens is the voltage that is applied to the piezo element is altered. And the higher the voltage, the smaller the droplet. So by varying the voltage, the amplitude, you can create different sizes of droplets or drops. Now, grayscale actually has well, I won't use the word waveform because that's something different, but has an amplitude, a waveform amplitude. I need to use it, but I'll explain later what a waveform actually is. And that waveform is chopped into parts. You can see it here. The best one is here on the right, where level 1, only the middle part of that waveform is used. Level 2, middle part and the one on the right. And level 3, all waveforms are used at the same time. So that allows you to have different drop sizes in one job. Okay. Example of grayscale heads are Q-class heads from Dymatics, but also the Psycho GS508 is a grayscale head. Heads that are an example of variable drop size, but not grayscale, are Epson DX5, for instance, DX6, DX7. Now, next to the voltage that is used to drive the piezo elements, you also have a waveform. And the importance of the waveform is outlined here on this slide. It's about print quality and about, well, how should I say this, security. It will avoid satellites. If there will ink build up on the nozzle face, so that improves the print quality, especially when you have no satellites. And satellites are little droplets of ink around the printed images that are unintended. They should not be there. It looks a bit like if you have a lot of satellites, it looks like mist in your prints. Fine-tune the print quality is also important with a waveform. To have a consistent drop speed, for instance, or the correct drop size for the image resolution. So actually matching the drop size to the resolution demanded by the print software. If you print something in 300 dpi or 600 dpi, you need to have the right drop size for that quality. And also, waveform is often used to tune heads so that they work very well with the original inks and not so well with third-party inks. So what a waveform does, in general, the voltage will determine the size of your ink droplets, while the waveform will determine the shape of it, how it looks. Okay, so the size, 10 picoliter or 6 picoliter, the waveform will determine if it's nice and round, if it's oval, if it's completely disformed. So that's why the waveform is so important. There's an example on the left. This is a typical waveform where you can see in this axis here. Sorry, back. In this axis, the pressure, which is actually taken care of by the driving voltage. And you have the time, and then you can see how the waveform actually forms the shape of the droplets. You can see the results on the right. And there's actually, these are not droplets on paper. These are actually droplets in the air. So between the printhead and your media. Okay. Now, printhead construction. How are they made, or what are they made of? This is a DX4 head, so typical head used still in a lot of printers. You have a nozzle face. Let's take one like this. So you have a nozzle face here, usually protected by a bracket that also secures it to the body of the printhead. You have electronics with connectors. Okay. You have ink nipples or inlets, and you have a manifold, which is this part here, usually containing the ink nipples. And also on this particular head, you have a head ID. And in case of Epson printheads, the head ID contains driving voltage and the waveform. Okay. So head ID, voltage, and waveform is information that comes with your printhead. We saw the head ID on the DX4. All right. In the middle, you can see a Toshiba CA4, and that has a waveform and a driving voltage as well. It's not written in numbers on the printhead. It's in the QR code. Okay. So let's take one here. This code can be scanned and will give you the exact waveform and driving voltage for that printhead. And usually it's on the box as well for a Toshiba printhead, but I always advise people scan the QR code. You never know, something went wrong and the wrong head ended in the wrong box, and you didn't verify the serial number, which is here on this head. So it's always better to scan. You can scan that with any QR code scanner on your iPhone, or if you must, an Android phone, but I would prefer an iPhone. So you scan this, and it will show you the result. You can verify if it's the correct serial number, the waveform. In this case, for the example that you see on the screen, AL4. Toshiba heads have waveforms from AL1 to AL6. They are used in Ose, Arizona, Fujifilm, Akidi, and Mimaki GF printers. And you have 3 voltages for a CA4. A CA3 only has 1 voltage, but the CA4 has 3 voltages. And it's always the first voltage is for the Ose printers, who uses only 1 voltage. And the next 2 are for Mimaki, where the last one is V1 and the middle one is V2, to keep things not complicated. All right, now back to the Epson head ID. You can see a full head ID in the image in the presentation. Here you can see that there's less numbers. All right, there's 51 characters in a head ID for an Epson printhead, and only Epson uses the full 51. Muto uses 33, Roland uses only 19 numbers, and Mimaki uses 33 or 19, depending on which printer it is. On the bottom, you can see the label on a Psycho printhead, in this case a GS508, which is used in Vutec printers, Vutec GS printers, among others. And you have 2 driving voltages there, which needs to be entered in the software. There's no waveform. The waveform is actually programmed in the software, and every head can work with that specific waveform. So they are constructed in a slightly different way. If we look at them and compare them to what we saw earlier, you still have a nozzle face, right? You have an ink inlet. You actually have a built-in damper on this one. You have the electronics. You don't really have a manifold. You have a frame where electronics, damper, nozzle face, etc., are connected to, secured to. So, talking about nozzle face, the industry uses only 2 materials for nozzle faces, mainly. There's some that use a different, but if we talk about 90% of the printheads, then it's either a silicon nozzle plate or a metal nozzle plate. And the differences you can see on the left and the text on the left. Silicon nozzle plates are always better than metal nozzle plates, even if they look fancy, like on a DX5, on some DX5. They call it gold plated. It's not real gold. So you think, oh, this is more expensive than the one in silicon, but it's the other way around. Silicon allows much more accurate drop placement, is more durable. It has compatibility with a wider range of ink, but metal nozzle plates are a lot cheaper and easier to produce. So metal nozzle plate printheads in general will be cheaper than silicon nozzle plate printheads. The image on the right is of the sapphire printheads, Q-class printheads from Dymatics Fujifilm. Okay, so the nozzle face, which is just a bunch of holes, okay, and every hole can eject an ink droplet, and you can see the sizes there of a typical head for an Epson TFP, a Spectra SL128, and a sapphire head. You can see the distance between two nozzles and the size of a nozzle. And for reference, on the bottom of this slide, I put the average diameter of a human hair, so you can compare that. Most heads, all right, have one nozzle row. This is a CA4, has one nozzle row. Okay. The cycle I just showed, one nozzle hole. Up to now, it's only Epson and some Ricoh heads that have more than one nozzle row per head, allowing more than one ink color to be ejected by the same head. Very popular, the DX5, right? 8 channels, resulting in 8 nozzles or nozzle lines. 180 nozzles, by the way, per channel or per line. DX6, same thing, 180 nozzles, 8 lines. And I would like to use the opportunity to explain that DX4, DX5, DX6, these are industry names. Epson never calls them DX4 or DX5 or DX6. That's something that the industry came up with. DX5, for instance, and DX6 and DX7, that's the same head. 180 nozzles per row, 8 rows. It's just a form, the shape of the head that is different. This is just a DX5 with a different shape, and they build it like this, so you can easily stack them in an array or in your carriage. If you need to stack these, if you ever did an alignment on a Mimaki GV5 who has 4 of these, then you know what I'm talking about. This is quite difficult. This is made to align and stagger, if you want. Okay, so the explorers are industry names, and that's what we work with. We had to give them a name because the names given by Epson, how should I say? They actually gave them a different name for every printer that they, nearly every printer, even if it was exactly the same printhead. Okay, so that's why the industry came up with DX3. There actually never was a DX1, DX2, DX3, DX4, etc. generations. All right. So how should you handle these things? Well, not like I'm doing now, but don't worry, these printheads are dead, as I call them. But it starts with yourself. You should always wear gloves when you handle printheads, and not because you should not get ink on your hands and you don't like to get ink on your hands, and it is not a good idea to get ink on your hands, at least most inks, because they are usually irritating for your skin. But because you have grease on your fingers, and if you touch the nozzle face, well, not this one, I touched it too much, like this one, then you can, I don't know if it shows on the camera, but you can see my fingerprint on there. So you have grease on your hands, even if you wash them 20 times a day, you still have grease. That's why we have fingerprints. Okay, so wear latex gloves if you're working on water-based and solvent ink printers. Wear nitrile gloves if you're working on printers with UV ink. You should also ground yourself. Wear an anti-static wrist strap. We just saw how sensitive this technology is, the sizes we are talking about, and any overcurrent will blow the micro piezo elements on heads like this, just like that. If you're lucky, they didn't, but you might just as well be unlucky, and then you have a dead head. Okay, so ground yourself and wear gloves. A word on cleaning a printhead. We had a webinar in the past. If you're particularly interested in how you should clean a printhead, I advise you to watch it. Just go to YouTube and type DIGIPRINT supplies and you'll end up on our channel, which, by the way, also contains a lot of videos on how to replace a printhead in a specific model, in a Roland X C540 or in a GB3 or in a GF 1615, etc., etc., etc. But the reason I'm still talking about cleaning a printhead here is that depending on the type of printhead, there's different types of cleaning that can be used. You see the traditional tools here, swabs and wipes, and none of them are made to clean a printhead. And I've been in the field way too much, so I know that people clean their printheads with wipes. I should rephrase that. None of the Mimaki Roland Muto printheads are made to be cleaned with the tools that you see here. Okay, if we're talking about a Cycle 540, then you can use a wipe. If you have a GS head in a ViewTech GS printer, then you can use a foam wipe to clean that. But then there's still specific rules that need to be applied. Swabs and wipes are used to clean the surroundings of the printhead, and that's very important as well, to keep the surroundings of the printhead clean. Any part in your printer that comes in contact with your printer should be kept in optimal condition, and that's capping and wipers. And I know you can ask yourself the question that this little rubber wiper that you put in your printer, that's okay to go over your printhead, but I can't touch it with a swab or a wipe? No, you can't. First of all, that wiper is in a condition where no dust can actually contaminate it. At least if you keep your printer decent and don't print with all the covers off, okay? Second, the wiper only touches the head in one direction. It will never rub. It will go like over it, and then goes down. So one direction. If you start rubbing and there's something in a nozzle, a bit of dust, and it doesn't need to be big, you know the size of a nozzle now, and you start rubbing, you will actually push it in inside that nozzle, okay? If it's on the wrong side of the nozzle and you only go like this, you can still have bad luck, but if you do a normal cleaning and it's dust, it will go out. The only things that don't leave the nozzle of your printhead are dried ink, and that's in very specific circumstances that you will have this. So wipes, foam wipes, swabs, you can use them to clean the surroundings. Here are some images that come from various user manuals from Roland, Mimaki, or Muto, where it's always advised to clean around the printheads. The one on the left, by the way, is this head. It's the SPT 510 head from a Roland AG 1000 advanced jet. So you can actually clean around it. You can clean here, so that's no ink. Maybe you can see that here on the silver board. You just clean this. Make sure that there's no ink left here, because any ink that is left on the surroundings of your printhead might end up on the nozzle face if it gets wiped. Okay. Always use the cleaning liquid if you clean surroundings of printhead, or in the case of Psycho and Spectra printheads, where it is okay to use a foam wipe or a wipe on the nozzle face itself, always use the original cleaning liquid that is compatible with your ink, not with your printer, with your ink. If you use original inks, use original cleaning fluids. If you use third-party inks, use the fluid that comes with the third-party inks. I can't stretch this enough. You don't want to start mixing or experiment, well you can, but it's on your own risk, with cleaning liquids that are not intended to be used together with ink. The result might be that there's some chemical reaction between that cleaning liquid and the ink you are using, resulting in gelling, which will definitely kill your printheads. Okay. So if you use wipes, this is how you should fold them. You should not just take a wipe and then start rubbing the face of a Psycho or Spectra printhead in a super wide printer. You should fold them in half and then in half again, so that you have an edge that has no seals, no edges of the original wipe. If you look at the first image, it's got 4 edges, and these edges are sealed, and they are a little bit rougher than the rest of the structure of the wipe. So that might be a magnet for dust, and it might be a problem for the nozzle face of your printhead. So you wipe your wipes, you fold them in half and half again, so that you have a nice round edge. You moisten that edge, and then you can clean the nozzle face of your printhead. Always in one direction, from back to front. You don't want to go from front to back, because otherwise, if there is some ink that stays on the carriage, it's much easier to see in the front than in the back. All right. Watch him wearing nitrile gloves, by the way. Good. How about installation, which is a part that we want to keep as general as possible. So, first of all, when you install a new head, you need to prime it. Okay, we've got some tools for that, for any Epson head. For other heads, like here, Psycho, you can just put a syringe in here. You don't need a very specific tool for it. Same here. This is the ink inlet on a Toshiba CA4W. Okay, and why you should prime a head is because most of the time there's transportation liquids in a head, and for some heads that are tested by the manufacturer, what they actually do is they load ink in that head, but not regular ink. It's very thin ink, and they print a nozzle test to see if that print head is okay. This actually happens inline in the manufacturing plant. So the print head is actually manufacturers put together, and then in the end, in one nozzle, there's a line going in printing a nozzle test. Okay. Some of that transportation liquid or some of that mixture of thin ink stays in the print head. Okay, and you need to get that out before you install the print head. And what we always advise, if you do this, is not just soak some cleaning liquid and then push it through the head. I'm done, head in the printer. No, you push some air through the print head carefully. Don't ever use too much pressure, especially on Epson print heads. They are very fragile and sensitive. So you will push around 15 milliliters of air, then some cleaning liquids, and then some air again. Okay? So that way, you are absolutely sure that any liquid that was in that head that might or might not be compatible with your ink is out of that head before you use it. Okay. Data cable. When you install a print head, it is connected to usually a slider board or a CR board or whatever name they come up, Mux board. It has some connectors on there. This DX6 actually has 8 connectors on it. A DX5 and a DX4 have 2. And there's a flat cable that is connected to these connectors. So a little word on flat cables. Sometimes you need to fold them. And if you fold them, you can fold them only once. If you fold it in this direction and you say, ah, that was not good, and you fold it back, it's broken. Throw it away. Okay, so you can fold it only once. That's one remark. And second, you should always insert them with two hands. So if you have your print head and you take your cable and you do like this, don't do it. You always hold the cable with two hands. So you can insert it evenly and correctly into the connector. You can see some of the common defects that you have on flat cables, and these are defects that are not always easy to see. Here it's clear that the one on the right, the pins are not parallel anymore, and that the side is crippled. But if they are out of center, that's already a bit harder to see on a data cable. And this is a reason why we always advise customers, if you replace a print head, replace their cables as well. They don't cost you much, and they will save you a lot of misery. Even if you didn't order them and you replace a print head and you connect the cables and you did something wrong, then you have to wait until you have new cables. So order the cables with your print heads. Right, dampers. Okay, a little word on dampers. Label them, especially in this example. This is a GV5, so it has 4 DX5 print heads, 8 dampers per print head, so you've got 32 dampers in there. So label your dampers so that you know in which position you can put them back. Also, get them out of the way. And with get them out of the way, I actually mean make sure that they are wrapped in wipes or in a paper towel or something, because they will always leak a little bit of ink, and you don't want ink leaking in the wrong place. And of course, don't touch the window, especially when you take out dampers on these typical, these are valve dampers. If you touch that window and you press it too much, you actually release ink. The whole idea when you replace a print head with the dampers is that they don't leak ink on any of the parts inside of the printer. Right, and of course, tools. Use the right tools for the job. I know this is something that you find obvious, but I still see a lot of people using the wrong screwdriver, using as a plier that is not really fitted for the job. Just get yourself some decent tools and use the right tool for the right screw, the right bolt, the right cable, and the right tube. Around the print head, because the print head is not alone, we already talked about wipers and capping. See that in a minute. But you also have a board. So the flow of electronic commands inside your printer is usually from the main board to the print carriage board or slider board or CR board. They all have different names, and then it goes from there to your print head. Your print head is usually protected in your printer with a fuse, but a fuse is on the main board. So if you blow a fuse, you can replace it and your main board is fine. But usually your print carriage board, slider board, or CR board will have died. Is there a way to see that on a board? Unfortunately not. You have to measure it. If you want to know if all pins on the connector are still working, you actually have to measure that. So you can't usually see it. If there's something wrong with your main board and it is a fuse, you will see it, of course, but not on the carriage board itself. Okay, capping, same as cleaning print heads. When you clean around the print heads, you need to clean your capping. You need to keep them moist. That's most important. And you need to keep the rubber that acts as a seal. You need to keep that flexible. And then wipers, we talked about wipers as well. You got different type of wipers, rubber wipers, felt wipers used mainly in Roland printers, but you can also have wipers in HP Cytex. The one on the right is for FB500, FB700. So these should all be kept in optimal condition. Now, when should you replace the print head? Well, there's 3 reasons. When it's physically damaged, you can see in the image below that this is physically damaged. It has a dent. maybe there was a head strike. So that's very obvious. It's physically damaged. There's a dent on the nozzle face. There's, by the way, if you're lucky and that dent is in between two nozzle rows, it might still work for a while. There's a connector that is loose or broken. There's a ink nipple that broke off, physically damaged. Sorry, replaced the printhead. Yes, but electronically damaged is how should I say, not something that happens a lot, but also not easy to determine whether it's electronically damaged or there's something else wrong in the printer. It can happen with overcurrent, and with electronically damaged, I really mean the electronic ports, not so much the nozzle face or the no, not the nozzle face, the micro piezo elements and stuff like that. I really mean the electronics. That can happen when you have overcurrent, and you will always see it in your printouts. If it's electronically damaged, seriously, the head doesn't print at all anymore. If it's, for instance, a connector, some of the connections here are loose, that will partly print. And you can see that immediately when you print a nozzle test, it's like half on there, okay? Third reason why you need to replace is because the head is retired. I call that retired. It just reaches its maximum actuations. The piezo elements start to function not normal anymore. They don't retract enough anymore. They don't come back fast enough. So it reached its end of life and it's retired. And a typical print head, like the Epson print heads, like Spectra print heads, Toshiba, also the Ricoh and the Konicas, they have around 10 billion actuations per channel, okay, per nozzle, not ink channel, per channel. So 10 billion actuations. You can do the calculation. Just see how many drops you need for an image of 1 meter by 1 meter at 600 dpi, and then you can start to predict the life of your printhead. Okay, so there's enough reasons why you should not replace a printhead. The indication whether you need to replace a printhead or not is usually, well, your printout, and then you verify it with a nozzle test. So your nozzle test. And we have an excellent webinar, I think we ran it 2 or 3 months ago, about what nozzle tests can tell you about the condition of your printer and the condition of your printhead. So I would advise to have a look at that webinar on our YouTube channel or on our Zendesk support website if you want to see that. Okay, so let's go back here. And I'll open the chat so you can ask your questions. Let's verify. Yep, it's open. Fire your questions. I just saw my video dropping. I hope that didn't happen too much during the webinar. How many square meters does what mean, Mirko? The actuations? That depends on the resolution. Any printer can print in different resolutions, and the head has its maximum resolution as well. It's when you have a printer with multiple heads that you can achieve higher resolutions. DX5, DX6, the physical resolution of a printhead like that is 180 dpi. So it really depends on the resolution, but it also depends on the density, because a lot of printers use multiple droplets in the same place to have a higher density. So you can't translate the 10 million typical actuations. You can't really translate that to square meters, it would probably be a range from this to this, like from 2 million square meters to 4, something like that. But not really, just an example. Any other questions? The Ricoh Gen 4. The Ricoh print heads are a lot like the Epson print heads. So any advice that goes for Epson goes for Ricoh as well. They're a bit more robust than the Epson print heads. But in terms of nozzle phase, nozzle diameter, nozzle spacing, etc., they're just like Epson heads. And Ricoh also have heads with multiple channels. Gen 4 actually can drive 2 channels. Gen 5 can drive 4 channels. So you should apply the same care that you do to Epson print heads with Ricoh heads, Ricoh print heads as well. Sorry, that was difficult. If there is still air left in the dampers, you replace the print head, you connect the dampers again, there's air left in the dampers, you will actually push them out by doing cleanings. Especially if there's only a couple of bubbles left. Yeah, it's like the mileage of a car, I think, Martin. You can do 200,000 kilometers with the same engine that another person does 400,000. That depends, Color Worlds. Which printer and head are we talking about? So if the print head is clogged and you can't get it out with a normal cleaning set, then you will need something stronger like an ultrasonic or a printhead cleaning tool. And it's clogged because there's dried ink in there. There's nothing else. It will never be clogged because you have dust or debris or something else. It's clogged because you have dried ink. And you need to find a way. Dried ink is actually the biggest enemy of any print head. On Ricoh heads with ultrasonic, we have very, very good results. So if a print head cleaning tool fails on it, and I should check with Ricoh heads what you could use if you can connect a syringe directly, but I don't think so. Yeah. Why is a DX5 damaged after installation? What is its behavior? If you print a nozzle test, is it completely blank? Are there still some colors printing? What we also advised, and you can see that in the webinar about nozzle tests, is never print just one nozzle test. Print a nozzle test, do a normal cleaning, print it again. If your nozzles that were out in the first test came back, but others are out, then we're talking air. So it all depends on what you mean, Robert, with damage after installation. It ink lines across the media, and there was no ink coverage, and it was not touching the media, because that's strange. No, no, it's like a faint gray line that you see, Steve. No, it's not an electrical. There goes my video again. Ah, DX5. And on which printer? Color Worlds? Is it okay to run a print head without its own head ID? I suppose you talk about DX4, DX5, etc., etc. Yes, it's okay. Yeah. Will you have the optimal quality? Probably not. If you're lucky, you will, and otherwise you're not. And the reason I'm saying this is that waveform doesn't really matter that much on Epson heads. It's much more for the bigger heads. But voltage, of course, is important on Epson heads as well. Epson, however, uses a very, very narrow range of voltages in their print head. So you're never far off, and your droplets might be slightly deformed, but droplets on Epson heads are so small that you usually will not see any difference in printed images. With UV ink, Martin. Yeah, ultrasonic. There is a chance. Yeah, not with a syringe, and if it's already a few months with clogged nozzles, then with ultrasonic, yeah. That's good advice, Martin. It might be a cable problem. Yeah, or well, or the print carriage board, but behavior like this is 99% cable. Print carriage board, an electronic board either works or it doesn't, and it doesn't show this kind of behavior. Did you replace the cable at the same time, Steve? Okay, so RG900C, and I need to scroll back to, yep, on a Muto RG900C, it will recognize the heads automatically. Oh, ValueJet VG1624, that I need to verify. I just swapped two things, sorry about that. Using SG. On the SG640, you have these heads, DX4, and we have an excellent head cleaning tool for that, print head cleaning tool for that. Check our website, just look for DX4 cleaning, and you will find the tool I'm talking about. Sorry, Robert, I don't really understand your question. Can you rephrase? Technology-wise, Pierre, yes. Solvent and Aqua's heads are the same, and sometimes they are exactly the same. It's not always so that the solvent head has a solvent-resistant manifold and the water doesn't. Sometimes even the water-based heads have the same manifold, and it's also solvent-resistant. Good morning, Jamie. That depends on which printer you have. If you replace a printhead in a Roland, then let me think. Yeah, you do, because Roland doesn't use DX5. DX5 is a printhead that is usually installed on its own. Only in the GB5 you have 4, and you don't need alignment. That's the advantage of the DX5. All your channels are in one head, so you don't need to align them one to another. But if you have DX4 and DX6, then you will have some kind of alignment. I think the Printhead Doctor is a good device. It's an ultrasonic cleaner, just like our Clean Sonic, and it's an excellent tool. It just costs a bit more money. Yeah, but I worked with it, and yeah, it's good. Does a good job. What do you mean with hit crooked? If you take a printhead, first of all, make sure that there's nothing left in the printer. You can actually store it in a box like this or any other box, right? Should you wrap the nozzle face? What I would do is what I explained to you with priming. Just push air first, then cleaning liquid, and then air to make sure that there's no liquid left in the head. Then I would clean this swab. There goes the video again. With a swab, okay? And then I would put it in a box and that's it. Not especially in a dark place or anything. You don't need to cover the nozzle face with a wipe. You know, we said, and it is like this. It's not only that you shouldn't touch the nozzle face with wipes and stuff like that. So in a box like this, when you put in the head, I don't know if you can see this. Yeah. So the nozzle face is not touching anything. You just close the box like this. And if there was actually no liquid left in that head, you can keep it for months like this, even years. You have fluctuations in the voltage. You actually have fluctuations in the voltage to which the printer is connected. I mean, you have fluctuations on your power network in your company. That's not a good thing. It will not affect as much the quality of your prints or affect your print head, because any good printer actually filters that, but it could be harmful for a lot of other parts in your printer. So yes, I would look for a stabilizer. I'm not gonna comment on third partyings. I'm sorry, I can't recommend third partyings for the simple reason that I don't have enough time and resources to test all of them. If the nozzles really are crooked and you need to replace the printhead, Sergei. For the people that don't really have the address yet or addresses, you can use this, but also this email. But of course, we strongly advise you to use our Zendesk support website, because then your question is available to all. How do you use our Zendesk support website? You just go to digiprint-supplies.com, and in the upper right corner, you will see technical support. You click on there, and it will take you to our Zendesk support website. If it doesn't, you need to log in to our website, just like you would do when you order something, and then click technical support. And then you can open tickets, ask your questions, look at our manuals, look at our videos, etc., etc. Aha, interesting question. No, unfortunately not. I'll show you. Here are the electronics in between, running from here to here, and this is screw here, and this is screw there. If you take this off, you can take the little metal bracket off of it, but the rest is glued. And if you look very good or very carefully, you can see that these two ink nipples go here in the middle into the head, so they go straight through the electronics board, and that electronics board is actually glued to this part, this upper part here. Okay, so you could try, you know, but my guess is you will end up with a completely dead head if you try that. Same with DX5 and DX6, by the way. Just, I don't know if I have completely. I have only part of a completely. This is you can actually see if you look, you see the circles to the left and the right of these circles. You can see the nozzle lines. Is DX5 this, by the way, and these are actually the ink chambers, and all this glue here. All right, that's why the electronics board is glued to. So Epson glues heads. All right, everybody, thank you very much for watching this webinar. Hope to see you again next month. And like I said in the beginning of the webinar, you can watch the webinar again on our YouTube channel and on our Zendesk support website. Thank you very much. Have a nice day. Cheers.